stream from Try Again Dev, where we know that practice makes progress. I'm back from a little Menti B break, and today we're gonna solve a problem that I know I've solved before. However, yeah, I need a win, truly. So let's do this one. Alright, this one is linked list cycle detection. As always, I'm gonna go for the JavaScript. Okay, so given the beginning of a linked list, head return true if there's a cycle in the linked list, otherwise return false, okay? There's a cycle in the linked list if at least one node of the list can be visited again by following the next pointer. Internally, index determines the index of the beginning of the cycle. Oh boy, okay, if it exists. The tail node of the list will set its next pointer to the indexed node. If index is -1, then the tail node points to null and no cycle exists, okay? Alright, that's the way they set up their linked list here. Note, index is not given as a parameter. Head index 1, 2, 3, 4. So, from what I understand, index is the value. From reading the question originally, I was wondering if they wanted us to return that value, but it looks like they want us to just return true or false based on whether there is a cycle, so that makes it easier. Okay. Alright, and then, so, let me open Paint, that's what we usually do. So, and like, let me be mindful of the chat line, it's usually about there. So like, the way I was, taught to do this, because as I mentioned, I've done it before. So like here we have 1, 2, 3, and then 4 points back to 2, right? So we'll have 2 pointers. We'll have the first pointer going slowly, and we'll have this, or maybe I should do this in different colors to make it a little easier. First pointer going slowly, and like essentially we'd have the second pointer like skipping one each time. So like we'd set the second pointer here the first time, and then like here the next time, and then let's look at round 3 of this. We'd have this be the third one, and this would be the 4th place it goes, but then like, ta-da, here, eventually, they both land on the same node at the same time. Is this the optimal time complexity? Like, no, because if there's like 1,000 of these things, like it'll take a while for us to find that cycle. The other thing is, that we could look at is like, if we're doing this, right, and like, we have our slow pointer going one at a time, and like our fast pointer going faster, it's like 1, 2. From here, the next node is null. So like, that means that we've like hit a point where we could return something. So this is a return point, we return false. And this is a return point, we return true. So like, let's see what their ideal time and space complexity is, because this one definitely, it's O of n based on the length of the linked list. And space complexity, I mean, technically we don't have to save anything. If you wanted to make it more time efficient, you could save the previous node's value. So like when we get back to this first thing, if we get like here and this other one is like visited this one, then like, we'll have a higher space complexity by storing the node's values, but like a lower time space complexity by storing the node's values, but like a lower time complexity. So let's see what they're looking for in their answer. Aim for a solution with O of n time and O of 1 space, where n is the length of the given list. Okay, great. So that tells us that we're not going to like save the previous visited nodes, but O of n time means that we'll go through every node at least once. Or, multiple times, but once it's not like a for loop or a nested for loop or something that's increasing our time complexity. So, okay, let's write ourselves some code. So, let's see what we have. We have value and we have our next for each node. Okay, and we're not constructing things in this case, which is fine. And we take in the head node. So head is going to have a next. Part of me wants to write this recursively, but like, I'll put a pin in that for the moment. Anyway, here, so let's see. What is our base most condition, right? If head.next equals null, return false. If head.next, right? Yeah, equals false, or what was it? -1? Internally, index determines the index of what does index have to do with anything? There's a cycle, at least one can be visited again by following the next pointer. Internally, index determines the index of the beginning of the cycle, if it exists. The tail node of the list will set its next pointer to the index node. If index is -1, then this, okay. So, if index is -1, then this, okay. So, yeah, I don't know what it's trying to really tell us with index, but I'm gonna just say the next value is -1. And if that's the case, return next. And then else, we could, how could we do this with the fast and slow pointer? So, okay, hey, look at this. Let's just try it, right? Or let's do an else if, so these two things are actually like nested together. Else if, okay, sorry, that's our guard case. So then let next, right, equal head dot next. Like, this is actually false. Right, yes, okay. And then, so what I want to do actually here is say if head.next is this, or if head, or like head.next.next is that, you know? So like the next value, like say we're here, this is next once, and this is next twice. If that's null, we can also return false, because then we can like make it a bit more of a recursive solution. So head.next.next equals -1. So like essentially if the next thing or two things from the next thing don't exist, then we can return false because we found the end of the linked list. Which honestly, I'm thinking this way of setting it up is gonna error if next is -1. Because it'd be like, can't find .next of null, you know? So like else if blah blah, then as we said, return false. Great, okay, so then next is head.next, or I'll say primary, just so that we have like different words here. Secondary equal head.next.next, and then we'll say if primary dot value equals secondary dot value, and primary dot next equals secondary dot next. Honestly, I'm like, if they're the same node, I feel like we should be able to just say if primary equals secondary. Return true. And then how would we get it to do the thing again? I think we would just call it on itself, like call the function on these other cases. So then has cycle of primary has cycle of secondary. Okay, let's see what's broken so we can try to fix it. Okay, great, has cycle is not defined. I think I have to do this dot. Cool, let's try that. That's funny, okay. I'm like wondering how big of a test case they did, but let's find out. Console log primary, console log secondary. Let's see what's going on. Okay, nothing as far as this is concerned. So actually, instead of this, what I think I want to do is call the function on the next thing. Has cycle of head dot next, which is essentially primary, but let's do it this way. Oh no, that's interesting. Let this equal that, let this equals that. Let's see if dot value helps. Interesting. All right. So let's see what we're doing here by checking out what we're given. Because I'm expecting to see like the list node, you know, that kind of thing. Right, there we go. Okay, val next. Okay, great. Undefined, true. Okay. Huh. Okay, so here's what I'm thinking is going on. I'm not actually passing the next value here. I'm just seeing if the things are within two things of each other. So I need to work out this two-pointer thing. So okay, so if we reach the end, we return -1. That code is fine. Okay, so let's let primary, or let's call this pointer 1. And this is second pointer. Okay. Okay, we also need something to be current. Let current equal head. Okay. Let pointer 1 equal current, and then let second pointer equal current. So like we start off with vert.next, so that we're starting off by like having them staggered. So then if primary equals secondary, return true, and then what are we going to do? So we're going to have the second pointer jump forward by two things. So, because like we said, or I'm just going to erase this to get our logic out here. Okay. Nice chunky eraser, we love to see it. All right. Okay, so let's draw again. Here's our chat window. So head, next, next, next. We have this as our cycle. We start with the first current being this one. Second pointer is here. So then what we'll do is we'll move the second pointer up 2 values and the first pointer up 1 value. And the reason for this is like apparently if you have a cycle eventually they'll get to the same point at the same time eventually. This next one will be here, then here. Oops. Because we're counting my 2's for this one. So like next, next. So it'll be here. and then this one's next will be here. So that's how we'll find it. So for the second pointer, okay, so oh here, need to update these variable names. Okay. So if it makes it down to here, second pointer equals second pointer dot next, and then pointer 1 equals pointer 1 dot next. And then we have to do this comparison again. Okay, so since we have to do this comparison again, let's do a while loop, right? Because that's what while loops are for. Doing things over and over and over until some condition is met. Right, and then, so while pointer 1 and second pointer and pointer 1 is not equal to second pointer. Great, okay. So then what we could do is bring these conditions back to the bottom here. So like if they equal each other by the time we wash ourselves through the while loop, I mean, I do want this here and here. Technically, these comparisons are great in both places. And if one of them doesn't exist, pointer 1 or not pointer, second pointer, return false. Let's see how this one does. Okay. I was expecting the while loop to chuck us out before this, but that's fine. I mean, I guess what we could do is put this into the while loop, because if we return, it'll break the while statement anyway, so. No, still. Okay, so one thing we know is that this second pointer next thing isn't working. So, I'm wondering how, okay, there's only 2 items in here. This is current dot next, pointer 1. Okay, so we could put something like that here. So, oops, where was that code that I just took out? Okay, if not pointer 1 dot next or not second pointer dot next or not second pointer dot next. So like pretty much if we can't proceed from one of these places, then we'll return that false and stop the train. Yeah, and if we can, you know, do the other stuff we mentioned. Oh, okay. Well, items with one value. Yeah. I thought that was in my edge cases here, but I guess not. Head.next is -1. Let's see. I mean, I just realized that up here I should also do the if not head thing. If not head, return false. Also, it's like if we get an empty head value. But that should go through this case where this value is 1 and the next is null. Yeah, I'm like, why are we not catching that here? Do you want it to be null instead of -1? What is going on? Okay, maybe? I don't know. Yes. Okay, well, that's funny because like that whole index thing it was telling us about is like the -1 thing is kind of not true, but like whatever. So, all right, well, let's go back and look at the code to, you know, talk about how we got to what we got to. All right, so this is JavaScript code again, and just a reminder, we don't know what's this place. We get to this place from practice and repetition, and this is an easy level LinkedIn problem that linked list problem that I've seen and done before. Years ago, but still before. Not my first time seeing it. But we're given a linked list, the head of a linked list to be more specific. What we first do is set up some guard cases so that if our linked list does not have a head, like if our input is just null or something, or if the next value is null, like anytime we get to a null as the next value, we know that we've hit the end of the linked list, and if we hit the end of the linked list, then we are told to return false. So these are our guard cases here to just return false if we hit one of those edge cases. Great. Okay, so then what we do is we set up a current, so that way we have like some variable that we're currently looking at or some point in the linked list, right? So like this is our current, this is our current, this is our current, great. Pointer 1 stays at whatever our current value is. Pointer 2 goes on, like starts at being the next value to the head value. So we start off with one pointer at 1, next pointer's at 2. Fantastic. Okay, but like what, let's say we have a one node linked list that points to itself. If they are currently pointing at the same element, then we return true. And that is kind of how we set ourselves up for the whole problem. Okay, so then now we did that technically edge case for like the beginning, if we have a linked list with one item that points to itself. Now let's do some movement with our pointers. So while we have a pointer 1, aka this value isn't null, and this second pointer value isn't null, and the two values don't equal each other, if we skip this guard case in here for a second, based on the conditions here, let's say we get to this point, that means that these values exist for the next, and the next. So like these things can step forward, and they don't equal each other, right? So that's like the case where like say the second pointer is at like 3 and the first pointer is at 2, let's say. So then the second pointer would step forward to here, step forward to here. The first pointer would step forward to here, so they're no longer at exactly the same place. And they both have values, so they're not like sitting on top of each other. So what is this in here then? This is saying that like if we have a case like this where pointer 1.next is nothing, then we return false, because when we have like a linked list that ends, we return false. Same if the second pointer gets to a null value, because that means it can be false. And the .next, this is where we actually want to go to. But remember, we can't go to something that doesn't exist. So it's almost like, you know, when you're crossing, or I guess if you're playing a game, and because lily pads don't actually support wait, but like, okay, instead of hopping across lily pads, let's say you're like, and this isn't what you're supposed to do really, but like, okay, sorry, I'm just couching safety, but I'm like, let's say you're hiking and there's a really small stream, like, you know, like a puddle almost of running water, very safe. And there are rocks so that you can walk across the running, like the water, without getting your shoes wet. But it's your first time crossing these rocks, so you don't know if they're stable. So it's like before you step on a rock, you kind of want to put your toe on it. You want to test it, you want to push on it, you want to make sure there's something there. So that's essentially what this guard statement is doing. It's like if there isn't one of these values there, then we can return false because we know that the linked list ends at some point. Anyway, so if there is not a place for us to step forward to, we can return false because just like at these guard cases, we know that there's an end of the linked list. And otherwise, we continue forward, and eventually, if there is a cycle, mathematically at least, the points will equal each other, or the linked list node, you'd be at the same node as we saw. So yeah, essentially, what would kick us out of this while loop is if these two things equal each other, or if some one of these conditions is impossible to meet. So if we can't step forward, we return false because it ends. And if we can step forward, that's our last guard statement here. Or like if they equal each other, that will kick us out of the while loop, but we have to make sure to return something. So yeah, thank you for watching if you are something. So yeah, thank you for watching if you are. And otherwise, have a great rest of your day. Remember, practice makes progress. Only perfect practice makes perfect, and nobody's perfect. So good luck with your studies if you are following along. And remember, people don't just start off as experts. We have to struggle to get there. Make sure to protect your mental health and your energy along the way, though. Good luck. Until next time, it's been Try Again Dev.